In today's video, we are going to look at calculating the determinant of a matrix. The determinant of a matrix is just a specific number based on some operations we perform to a matrix. That number is going to be the basis as to how we're going to solve systems of equations using what's called Cramer's rule and inverses. Those are going to be two different videos that you're going to see. So we're just going to start working on the mechanics of what a determinant is, how to physically calculate what it is, and then we'll actually start applying it in the next two videos. So to begin with here, we're going to look at finding the determinant of a 2 by 2 matrix. The 2 by 2 determinant is the easiest of the determinants. We can only find determinants of square matrices. So we'll look at 2 by 2s, 3 by 3s. I'll even show you a 4 by 4. The larger the matrix gets, the harder they become, the more tedious they become. Not necessarily that the nature of it is all that difficult, but there's lots of little mistakes that you can make along the way. You start getting very large numbers as well. So we'll focus on 2 by 2s and 3 by 3s. 4 by 4s are just kind of a plus to know how to do. How do I know that I'm finding a determinant of a matrix? As I've said earlier, a matrix is used as a capital letter. This is matrix A. So if I want to calculate the determinant of the matrix, what I would instead see is they look like absolute value bars. They're not. There is no absolute value of matrices. There's no division with matrices. Those two straight bars just mean the determinant. So when you know you're looking at matrices, you will know that this is the determinant of it. So don't forget that feature in it. The other way that you'll see it is DET, represent the determinant of matrix A. So this is my starting matrix. This is where I'm starting. This is the representation for determinant, and this is the representation for determinant. So in this situation, I'm going to start with a generic 2 by 2 ABCD. And don't blink or you're going to miss it. To calculate the determinant, you take your A times your D value, you go across. So A times D. And then you subtract B times C. And that's going to give you a value. That's going to give you a number. That's it. That's a 2 by 2 determinant. Very, very straightforward. But you have to know how to do 2 by 2 determinants. Otherwise, you won't be able to do the 3 by 3s and the ones that get more difficult. So we'll do this with some numbers. So we've got the first example on the left, 2, 4, 3, negative 1. I put the straight bars around it, which denotes find the determinant for it. I don't have to use any words, so that notation tells me I want the determinant. If this was a matrix, I would have tops on these. Do not get those confused, please. Two very, very different situations. So I want you to find the determinant of this matrix. So, again, as I said before, go across. Top left, bottom right, multiply. 2 times negative 1. And I subtract the opposite, 4 times 3. And that's going to calculate a number for me. So 2 times negative 1 is negative 2, minus 12. Negative 14 is the determinant. Again, a numerical value. That's it. So do the second one really quick, and pause it, go through it, and then make sure that you got it right. Be careful with the minus and negative in there. So after you calculate this, which is then 84. So again, just some numerical value. Be careful, the minus and negative is the same thing as plus and positive. That's the only thing that I can really see happening along the way is either forgetting that it's a subtraction sign going the other way or just losing them with the negative values. So very, very straightforward. 2 by 2 determinants. I should be able to give you a sheet of 100 of these and you should be able to do 100 of them in 2 minutes. Not that I'm going to do that, but that's how confident you should be in these. 3 by 3s take a little bit more time. There's a few more steps to them. But again, what you're going to get is a specific number. That's it. I'm going to start out with the generic case with the variables, and then I will show you what it looks like numerically. Please do not memorize where these letters go. It's not going to help you at all. It's going through the process. It's understanding what am I multiplying together, what am I adding or subtracting along the way. So we're going to start with the following case. I'm going to start with that top right, A. So again, this is a 3 by 3 matrix. I have A. Then what I'm going to do is I'm going to cross out its row and its column. So I'm just left with EFHI. That's a 2 by 2. And I'm going to have to find the determinant of it. EFHI. So A is going to be some number, some constant, some scalar multiplied to a determinant. Again, The bars here just mean this is a determinant, which is just a number. Don't take A and multiply it through to everything if you don't have to. You can, it's completely mathematically correct, but you're going to get bigger numbers to work with. Just calculate the determinant inside there. Again, there will be cases where maybe you do want to do the opposite direction, but most of the time that's not going to be the case. So now what I'm going to do is I'm going to remove this information. So that was the first case. Now, if you remember with 2 by 2s, I did my one situation and then I subtracted. Kind of the same type of thing happens here. I'm now going to go and subtract. Now what I'm going to do is I'm going to circle my B. That B is going to become my scalar multiplier. Just like before, I'm going to cross out its row and its column, and I'm left with DFGI. And that, again, is the determinant of a 2 by 2 matrix, which I said you should be able to do 100 of them in 2 minutes. Then, after subtraction, we go to addition. Just like before, I got rid of those lines, same thing. Get rid of those lines again. Now I go to my last letter, C. And it's multiplied by, cross out its row and column, D, E, G, H. Take the extra time to cross them out if need be. That way you just know you're correct. Now, I've got a scalar multiplied by a determinant, and then I'm subtracting, and then I'm adding. So I have all of these three different processes that are taking place. Now, I'm going to show you what it would look like if I do the determinant as well, but again, the idea is not to just memorize what this looks like. The idea is to actually just be able to put it into place. These are numbers. You're going to be multiplying them together, adding them together, subtracting, whatever the case is. They're going to actually be very simplified compared to this generic case. Don't forget when you're doing the 2 by 2 determinants, you are subtracting that second part. All of that bottom line there, that black, is just a single number. So, numerically, hopefully this will make sense when we put it all together. What I want you to do is I want you to see if you can start. I will give you the hint. Start with your 2. Cross off its row and its column. Start going that way. So go ahead and pause. And then after I do the 2, I work on my 3. And after I finish my 3, and I do my -1. I'm going to show you this. Be careful. It's plus, and then my scalar is a -1 times this quantity. If it would be minus, it would be minus a negative. Same thing with order of operations work out here. So don't let that confuse you. So I have that whole system set up. Again, as I said earlier, if you wish at this point, you could distribute those scalars inside. I don't want to have to deal with more than I have to. If I send through that -3, I'm going to have more negative numbers than I did before. Again, that -1 as well. So just be careful with it. My personal preference is to do each of the 2 by 2 determinants, then multiply those numbers through. So my first one with the 2 on the scalar, this part here is the same as that. Those 2 pieces are equivalent statements. Exactly the same thing. I just have to physically do that 2 by 2 determinant piece. So that's where you have to be really confident on those 2 by 2 determinants. Then I have to do -3 times 4 times 1 minus 7 times -2. Again, don't lose those negatives. Plus -1 times 4 times -3 minus 7 times 5. So now it's just some of your basic algebra skills. I mean, pre-algebra skills, just order of operations. 5 times 1 minus -3 times -2 is +6, and that's all multiplied by 2. -3 times, so that's 4, plus -7 times -2, so plus 14. Plus a -1 times -12 minus 35. So 2 times -1 minus 3 times 18. I'm going to change that to -1 times -47. And then finish it off. -2, -54, +47 gives me -9. Just a numerical value for a 3 by 3 determinant. Scroll through, take a look at what we've done, see if that makes sense along the way. This is the only 3 by 3 that I'm going to show you. I'm going to go on to next a 4 by 4. which again takes it just one more step further. I'm not going to do the whole thing, but at least I want you to see how it's set up. So for a 4x4, you are going to be using your calculator if you need to, because it's exactly the same as a 3x3. It's just a lot more work that's involved. You start with circling the 1 and crossing out its row and column, and that's multiplied by the determinant 6, 7, 8, 10, 11, 12, 14, 15, 16. Okay, just like before. And then I subtract 2 times, circle, cross out the rest of it, 5, 7, 8, 9, 11, 12, 13, 15, 16. And then I go plus. 3 is my scalar. Cross out. And then, what do you think comes after plus? Minus 4. And it's 3x3 determinant. Okay, so now I have a 3x3 determinant. You know how to do 3x3 determinants. You just did them. Look at all the work you have to do for one of the parts. That's where I'm saying these become very, very, very time consuming. It's exactly what you've done before. It just takes a little bit more time to go through the process. 4x4s are going to give you, again, a number. I don't even know what the number is. I just randomly made this problem up. So if you think about that, it's just going to give you a specific value that you are going to then use for solving systems of equations, either using Cramer's rule or inverses. I'm going to show you those in the next video.